All right, exam number 2, review sheet. I'm going to preface this whole thing by saying that if I take the time to shoot a particular problem right now, that means it is on that test, and you better make sure you know how to do it the way that I do it. So these two questions, question 1, A and B, solved by factoring. Now, I didn't only pick them because the solvers do them wrong, but I picked them because factoring is an important skill. And you need to be able to do it and show me that you do it right. Now, this equation is equal to 0. This one isn't. So the first thing you have to do is set it equal to 0. So how do you do that? Well, you have to add 40x to that side, right? 40 minus 40 is 0. And then you have to add it to the other side. So I'm going to add the 40x over to the left side so that it's equal to 0, so that I can factor it, and then use the 0 factor property. So you're looking for the greatest common factor here. I want the largest number that divides 24 and 40, which is 8. And then the common letter is x. So you're going to divide away 8x. 24 divided by 8 is 3. X squared divided by x leaves you with an x, plus stays there. 40 divided by 8 is 5, and the x is crossed out. Right? If you need to do this, then do this. Right? This is what I really did. I divided the 8x, right? You put it in the front, because it has to match what you started with. And then I just divided the 8x away. But I do that in my head. You don't have to write that if you don't want to. Now, if the product of two things is 0, one of them must be 0. That's the 0 factor property. What do they call it? Other things. Right? So you set each one equals 0. Yes, I have to see this step, so please show it to me. Now, don't do anything weird here, like do minus 8. You divide both sides by 8. But what is 0 divided by 8? You better not leave it that way. You better know that it's 0. Mistake number 1. Well, there's other mistakes, but you don't put, if you put 0 over 8 as your final answer and box that, there's a minus 1. All right, it's not. It's 0. Here you want to subtract 5. And yes, I want to see it. I want to see the work. This is your work. These are your steps. Divide by 3. So you get x equal negative 5/3. I'm going to write it neatly. Wrote it sloppy there. That's your second answer. Boom. That's it. Right? Set it equal to 0. Factor it. Set each factor equal to 0. Solve it. Now, the other one the solvers love to do wrong. The difference of perfect squares. All right? Again, another important factoring technique. Now, the problem says solve by factoring. You don't have a choice. You got to factor it. Something times itself to make 81. Well, that's got to be 9x, right? 9 and 9. 9x and 9x is 81x squared. And then something times itself to make 64. It's got to be 8 and 8. That's the whole point of difference of perfect squares. One gets the plus, one gets the minus. Set them each equal to 0. Now, just to save time in the video, this video is going to be like forever anyway. So you subtract 8, right? So you get 9x equals negative 8, and then divide by 9. Now, just to save time, I did the same thing there. Blah, 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 blah. You would get 8 over 9. So then you want to write your final answer all nice and pretty with the plus and minus 8 over 9. I mean, show the work. I'm skipping it to save like 5 seconds of time. So that's the answer. You can write your answer as negative 8 over 9 plus 8 over 9. I don't really care. But as long as you get both of them. All right, so for sure those two questions are there. All right, now I'm going to move on to question number 2. Okay, question 2. Again, notice I put 2A and 2B. These are good questions. Now, first one, right, they're both square root. So you know you have to do the plus minus square root at the end of this. You always have to get the squared thing alone. So this problem, your first step is going to be to subtract 3. And yes, I want to see that step. Now, here's the first trap. You see that 36 there, and you're like, oh, square root! And square root of 36 is 6. But what about the 2? This is a trap that is very easy to fall for. I know when I designed the one on your test, you can get a perfect square there. But you haven't dealt with this number yet. And the problem is you have to divide that 2 away. And you need to do it before you do the square root. You cannot take the square root until this is all alone. So you divide the 2 away, and you get to 18. Now, and only now, can you do the square root of both sides. Make sure you put your plus minus I don't want to see it just magically pop up later in the problem. Now, if you want to lose a point, just write 3 radical 2. But if you don't want to lose a point, why don't you show me that 18 is 9 times 2, and that 9 is a perfect square and comes out of the jail and stays in the front. Remember, he stays to the right of the plus minus. Don't jump him across to the other side. He's going to be directly in front of the radical 2. Pow. Look at how easy that is. My line got disjointed there. Fix it. So, important. A lot of little places you could screw this up. You could forget your plus minus. You could take the square root there with the 36 and then try to divide the 2 afterwards. None of it works. None of it works. You could jump from 18 to 3 radical 2, and I will take the point off. The solvers like to do that. The solvers don't put radical 9. Radical 2, why would it bother? It doesn't need to do that. It does other weird shit sometimes, but that's all wrong. So show everything. If you want all your points, you show me all the steps, right? This is important. It's more important now online than ever. Now, this one, ooh, the solvers have fun with that. What the solver would do is multiply that whole thing out, blah, 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 blah. It's a fucking disaster. It's ridiculous. That's not what you do. You know you got to take the square root. So you need to take this 16, move it to the other side. A lot of you don't like to do that. I don't know why. Why wouldn't you show that step? Some of you just magically pop, right? You're crossing it out from that side. That's how it gets to the other side, is that you eliminate it from the right. That's why you subtract 16, so you make a 0. Now, again, you're not multiplying this out. I want to get rid of this. I want to take the square root of both sides so I can kill that squared. So I'm going to do that. I'm going to take the square root of this side, which knocks out the 2, and I'm going to put plus and minus radical negative 16 on the other side. Right? That's the game. Take the square root. Now, I'm going to try to do it all in one step. I'm going to subtract the 8. Now, where does it go? Right there. To the left of that plus minus. Right? I'm going to cross it out from that side now. It's not there anymore. I'm subtracting 8. I'm going to move it there. To the left of the plus minus. Now, at the same time, I'm going to take this negative that's in there, and I'm going to put it to the right of the plus minus. It's got to go directly in front of this. Now, you could have done this in one move. Take the square root of 16 now. Don't do anything with this 4 yet. Take the 16 out of jail, right? Hook them up with the I. We don't write I4. We write 4I, right? Write it proper. You know, it just looks funny if you decide to write I4. It's weird, all right? You could have just immediately wrote 4I there. That's fine. You could go from here to right there. That's okay. Just make sure that you don't do anything weird with these. Now, you have to get rid of this 4. Right? You're multiplying by 4x, right? You times it by 4. So you have to divide by 4. So divide them all by 4 so you don't make an error, right? Cross out that 4, right? Because 4 divided by 4 is 1. Negative 8 divided by 4 is negative 2. Plus and minus doesn't change. It stays there. Those 4s cross out and leave you with just I. There you go. I would prefer greatly, again, I'm breaking my line. I would prefer greatly that you don't write negative 2 plus I, negative 2 minus I. Not only because the solvers will write it like that, but it's not efficient, right? You can write a single answer. You don't have to write 2 separate answers. Like here, I didn't write 3 radical 2 and then negative 3 radical 2. Why would I do that? I could just conveniently write plus minus. So write the answers as a single thing. Be good to go. And I really don't want to do number 3. I'm going to grudgingly do it. So be prepared. Okay, the quadratic formula. I mean, I really didn't want to do this one because I hate this question, but I know it's on your test. I'd be really negligent if I didn't do it. So I promise you on your test, it will not be equal to 0. And if you don't set it equal to 0, you're not going to get the ABC right. So the first part of the test, the first part of this question on the exam tells you, tell me what A, B, and C are. Well, there's A, there's B, there's C. Notice, a couple people did, like, they put letters there. This is a mistake, and it's gonna cost you. The A, B, and C don't have letters in them. They are the coefficients. They are the numbers in front of the letters. I mean, if people just write x squared here and x here, that's nonsense. Now, the next part of the question asks you for the discriminant. and what it means for the roots. So notice, I'm not writing the quadratic formula yet. I'm not. There's no quadratic formula here. I am writing the discriminant formula. So you put b squared minus 4ac. And here's where you got to be super careful. You have a minus, a minus, a minus. Oof, that's a lot of minuses. 6 squared is 36. Negative 4 times negative 2 is positive 8. And then you're going to multiply. See, do it in two pieces. You won't mess it up. Negative times negative is positive, right? 4 times 2 is 8. Positive 8 times negative 1 is negative 8. So there you go. So the discriminant, I guess you want to call it a D. D for discriminant is going to be 36 minus 8, right? Which is 28. Check. 28 plus 8 is 36. So what does that mean? Real simple. That you have real roots. All that means. You have a positive. The roots are real numbers. They could have radicals, but they're still real numbers. If that discriminant were negative, that meant that the radical has a negative in it, which means your roots are complex. Now, the quadratic formula looks like this. I'm going to tell you a super big secret, though. That's going to save you a lot of time. Whoops. Crap. I forgot my 4. It doesn't fit in there nicely. There we go. All over, remember the whole thing. Don't just put the line underneath the radical part. You already computed this, so you can totally cheat. I know I need to do negative b, right? Let's highlight them. I need to do negative b plus or minus radical, but I already did that. Look, I already did it right here. Why am I going to do it again? I already did it. I got 28. Put the 28 here. All over. Remember, the line goes over the whole thing. Don't just put the line. I see people do this. They do that. They put the line here. Wrong. Don't compute it again. If you're watching the video, right? If you're watching this stupid ass video, don't compute it a second time. What if you do it wrong? I see students do this. They tell me the discriminant is 28, and then they screw it up here, and they get a different number. What sense does that make? But people do it. Why would you compute it all over again? But it's in the formula. But you already did the b squared minus 4ac. You did it once. You already know it. Just put it there in the formula. And then over 2a. Now, what's a? A is negative 2. Right? You don't have to compute it again. You already have it. Just throw it in there. So it saves you a lot of work. That's why I make you do it separately. It defeats the whole purpose if you do it again. I'm trying to save you work. So don't do it a second time. Now, 28 is going to be 4 and 7. Right? Now, remember, I told you, there was a little trick I told you. What's 2 times negative 2? Negative 4. Now, I told you the big magic secret. Whenever you see these two negatives, make them plus. A negative divided by a negative is a positive. So you cheat. You make them plus. So now what do? Now you have a positive 6, right? It's not negative anymore. I switched it with the bottom one. He was minus and he was minus. I switched them. Take the 4 out of jail. Make sure he stays in front of the radical 7 and to the right of the plus minus. And then you have a positive 4 on the bottom, right? That's what x is. It's over. Just notice that 6, 2, and 4 are all even. I don't give a damn about radical 7. He's in jail. He's not affected by anything I do outside of jail. I'm going to cut everybody in half. So take half of all these numbers. Half of 6 is 3. Half of 2 is 1. You can write a 1 if you want. And then half of 4 is 2. Pow. There you go. Done. That's it. All right. So you compute the discriminant separately because I asked you to. So then just make sure you put it in the radical. I already said it 40 million times, but I hope it sinks in your head. Don't do it a second time. You don't need to. It's not, how are you not showing me work? You showed me the work right here. You're not going to lose points. Whatever number you get there, put it in the radical. Just put it in the formula. You already have it. I'm trying to make it easier for you. I'm trying to make you do less work. So you can just put that number there and then break it down. Look at how fast it goes from there. And then, right, break it down, switch your signs. Now, again, I want to point this out. I shouldn't point it out, but I'm going to point it out. The solver will take these two and move them to the other side. Or the solver will take all of them and switch them and make this plus, minus, plus. If I see that done, problem's wrong. I'm marking wrong. You can't alter the original polynomial. The original polynomial is negative 2x squared, da, 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 da. If you go switching it, you have a completely different equation and a completely different polynomial, and that's not the one you started with. You have to use the formula on the one that I gave you, not an altered one. So don't change it. You leave it the way it is. You subtract this over, but you can't change this. You cannot make this 2, negative 6, and positive 1. Do not do this. If I see you do it, it's going to be wrong. And I'm not going to be nice about it either. All right, so that's 3. No, I didn't want to do it. It took forever. Okay, question 4. Finally, an easy one, right? Vertex, very simple. You put negative b over 2a. I mean, I need to know what a and b are, so I'll write them. A is the number in front of x squared. B is the number in front of the x. Now, a lot of people screwed this up on the quiz. You're going to be very careful. I mean, really careful. B is already negative. Right? You have a negative in front of the b, but b is negative, so you have negative, negative. Now, a is also negative. Oof, a lot of minuses. You got to really be careful with what you do here. Like super, I'm seeing my lighting is all screwed up. Yeah, it's a little better. It's getting dark, light. Negative, negative makes plus. And then, again, negative and plus. Right? You have negative, negative, it's positive. You have a positive and a negative. It's negative. Plus, minus. I mean, minus, plus. Plus, minus, same thing. When the signs are different, you multiply them, you get a negative. When the signs are the same, you multiply them, get a positive. Now, a positive 12 divided by a negative 4 is negative 3. Yay! Well, almost yay. I mean, I need a point. I only know half of it. So you got to take this dude, put him back up in the original equation. The original equation has a y in it and x's. But now that I know what number x is, I can figure out what number y is. Be very careful with your signs here. It's also very easy to screw this up. This is where people don't screw this up. People screw this up. People will do 2 times 3, which you can't do. You can't hop the fence with the power on. You cannot hop the fence with the power there. You have to shut the power off. So first you have to multiply negative 3 squared. Right? Do negative 3, do the power. Then, I may as well do here. Negative and negative make positive. 12 times 3 is 36. Plus 3. Now I'm going to multiply that, right? It's negative 18, right? 9 times 2. That's negative. I add that together, right? You get 39. 39, take away 18. I mean, it's a pretty big number. You get 21. Yay, 21 to drinking age. So, there you go. I'm not a huge fan of, how big the number came out, but it is what it is. This is what it came out to. So, I know on the test I make the number a little smaller. I tend to make this single digit. So, that's a little hint, the secret. I don't like the number that big. So, when I design the one for your test, I tend to make the number smaller. But this question is a gift. You should not get this wrong. Right? It's pretty simple. Use the formula. All right, question 5. I got to point something out as I'm doing it, but this question again, real easy. I want the x-intercept. I want the y-intercept. The vast majority of you are awesome about labeling that properly the way that I do. You write x-intercept, y-intercept, you do it. Here, you're going to set x equal to 0. You know I'm going to do that one first. Here, you're going to set y equal to 0. Let's do the y-intercept first because it's easier and faster. Let's get it over with. Replace all the x's with 0. It doesn't get any better than this. 0 times 0 is 0. 8 times 0 is 0. If you add up all this crap with 20, you get 20, not 0. So the y-intercept, x was 0. Look, there it is. Y was 20. It's always the number that's by itself. Easy peasy. There's a joke. Get that over with. Now, to do the x-intercept, you have to set y equal to 0. And here's where I'm going to point out. If you go back and look at question 1 on the practice test, it had A, B, C. And I only shot A and B. Why didn't I shoot C, right? But solve by factoring with a trinomial. Well, look what you do here. See, test design is about not being repetitious. I have you solve by factoring with a GCF and a difference of perfect squares. But of course, I want to see you do a trinomial with factoring. Well, here it is. So it's built into a different question. So I don't need to ask you question number 1C separately because it's built into another problem. Now, the question is, should you keep that negative there when you factor? And if you remember me doing this in class, I told you your signs are going to be all over the friggin' place if you try to do this like that. Don't. I cannot, this is my original dude. Negative x squared, da, da, da. That's my original guy. But when I set him equal to 0 to solve, I don't want to keep that x squared negative because it's going to create a fit for me when I factor. I'm going to make a mistake with the signs if I keep that negative there. So I'm going to cheat. I'm going to divide everything by -1 and switch everybody. Now, here you get 0. That's the whole point. It doesn't, I'm going to switch. Make this a positive, make this a positive, and make this a negative. Oh my God, so much easier. Now I can do what I always do and just put x. I don't want to put x minus x. That's why I switched them. Now I need to make 20 and then I need an 8 in the middle. So it's got to be 10 and 2. And I need a positive 10 and a negative 2. Don't forget your equals 0. This is very easy to forget. And if I have to write it for you, point. So plus 10 minus 2 is plus 8. Positive 10 times negative 2 is negative 20. So I know that it works, okay? So then you set each one equal to 0. Now here's where I'll let you cheat a little. If you want to just jump to here, that's cool. But I'm not done, right? I got to write my answer as points. These are x-intercepts. These are coordinates that you would plot on a graph and make a picture. So you want to write them as points for me, right? Y equals 0. Look, there it is. Y equals 0. So you always get 2. You always get 2 x-intercepts. Not always, but the ones I give you will. And there can never be more. This would be a good true-false question. There can never be more than 1 y-intercept. You can't cross more than once, but you must cross. You will always cross the y-axis. There's no avoiding that. I can make you a parabola that doesn't touch the x-axis. Look, there it is. But it crossed y. It will always cross y. So if you see a true-false like that, just saying. All right, the problem I've been dreading, the circle. It's not that bad. It's just drawing is a pain, and it's a pain for me to do it. Now, I took the liberty of moving the x's together. The original problem had this. Oh, that should be a y. It had the 6x and the 4y separately. So your first step, right? Subtract the 4 and start leaving yourself some room, right? Create a gap. Leave yourself space because you know you got to complete the square. So I'm going to leave gaps and I'm going to put the -4 over there. So now again, I'm going to play my game. I'm going to take the numbers in front. I'm going to do them one at a time. Take the number in front of the x and cut it in half, right? That's +3. I'm going to square that. So that's +9. So I'm going to add 9 here. But you better make sure you add 9 over here. Right? Now I'm going to take half of -4. Be very careful. This is -2. Keep the sign, right? Square it. -2 times -2 is +4. So I'm going to add 4 here. And I'm going to make sure I add 4 here. Right? Put a little squiggly to differentiate. Now, when you factor, this is important, right? You're looking at this whole thing and this whole thing. But it's really easy to do because these numbers that you cut in half there, these numbers that were half, that's what you put. You're going to put x. There's a +3 there. Write that, right? That's half of +6 +3. You cannot screw up the signs here. You see that plus? You better make sure that's there. Where does it go? Right there. You can't lose this plus, or it's not a circle. Now you're going to put y, because it's the letter y. You see that -4? You cut it in half, you got -2. That's what goes here. -2, and then the squared. Make sure this friggin' plus is here. I see students all the time, they write this down. This is not a circle. I don't know what the hell that is. Got to put the plus. Equal, well, let's see. 4 minus 4, those are gone. And you just get a 9. There is your standard form. So the beginning of this question says, write it in standard form. Boop, done. Complete the square twice. It's not that bad. The next part of the question says, tell me the center and tell me the radius. Now, once you have it in standard form, you read them right off. This is a piece of cake. Switch, switch. That becomes minus 3. That becomes plus 2. That is your center. That's the dot in the middle of your circle. The radius, you take the square root. Remember, this is r squared. So you got to take the square root. So the radius is 3. That means, unfortunately for me, you're going to go up 3, down 3, left 3, right 3. It's more of a pain in the ass. I'm pretty sure on the test I have the radius being 1 or 2. I don't want you having it. It's very hard to draw a radius 3, 4, 5. It's too big. The circles are huge. You got to go all these points. Now, I took the liberty of making a grid. Wish me luck. All right, so -3, 2. You're going to go left 3 and up 2. So I can see it's right there. And draw my dot right there. That's my center. Okay, so now starting from your center. This is important. I've seen people come over here and go up, down. This is ridiculous. You got to start from the middle. So starting from your middle dot, first I'm going to go up 3, then I'm going to go down 3. So from here, I'm going to go up 3. 1, 2, 3, right to there. Then I'm going to go down 3. Now be very careful. You cannot hop over the x-axis. You got to count it. 1, 2, 3. I can already see it's not going to be perfectly circular. I didn't go down far enough. I'll try. Make it better. Now I got to go to the right 3. 1, 1, right? 1, 2, 3. Ooh, I landed on the y-axis. That's cool. Now I got to go left 3. 1, 2, 3. Now you have to label them, but I'm going to connect them first. Again, I'm going to just try to make circular arcs. I missed. Make my dot bigger. Then it doesn't look as obvious that I missed. Make a circle. Boy, that came out way darker. Let me do the tip there. Fix this. You don't got to make it perfect. I'm showing you that you don't got to make it perfect. I don't make it perfect. I mean, I make it circular. I'm saying that, and this ain't going to be circular. There you go. It's always easier for me to go up as a righty. I mean, it's weird colors, but some of it's darker. But it's a circle. I just read off the points. It's really easy, right? I do it based on the center. I know that everything here is 2, right? That this point has to have a 2, and this point has to have a 2. I mean, you can just read them off the damn grid, right? This is 0, 2. This is -6, 2, right? Just go 1, 2, 3, 4, 5, 6, right? -6, 2. You just read them off. Here, I know that I went -3. Like here, I know the x on both of these coordinates is going to be -3, right? I went 3 to the left. So I know they're both going to be -3. So this dot, right? It's -3, and then it's up 1, 2, 3 more, so it's up to 5. And then this dot was -3, and you're down 1. You must label them. You have to label them, right? The question clearly says, clearly label 4 points, right? So you have to do the 4 points. I actually do that pretty good. I could make it darker, but sit here and waste time. All right, so complete the square twice, put it in standard form, tell me the center, tell me the radius, draw the center, and then go up, down, left, right, make your dots, figure out the coordinates. If you want to write them, you don't have to write them on the circle. You can write them separate. Some people did that. But, it looks nicer if you put them on the circle itself. It's also easier for me to grade. All right, so that's the circle question. It's worth a huge chunk of points. I think it's worth like 8 points, but this is worth a lot. you making the thing and telling me what the 4 points are is worth like 4 points. I don't care if it looks perfectly circular. Mine actually came out pretty good, but as long as I can tell that it's, circular, and you have the points there, that's, you won't lose many points, if any. All right, we finally made it to 7. I did promise I'd do them all. I want to, but I will. So the first question you need to be very careful with. I gave you the parabola in standard form, right? That was the standard form with the H and K thing. So remember, to figure out the vertex, we took this number and we switched it, and we took that number and kept it the same. Now, if you were supposed to take this number and switch it, and you got -4, then the number that had to be there had to be +4. This had to be a 4. Remember, this has nothing to do with anything except whether it goes up or down, and if it's skinny or not. Even if this was a -2, it doesn't affect this. So switch. So H had to be 4. That's an easy one. You shouldn't get that wrong. Now, even though 7B is a fill in the blank, it actually requires a ridiculous amount of work. So to do the x-intercepts, right, you set the y equal to 0. Now, I know why I asked this one, because I want to make sure people factor this right. You factor out the 2x, get x minus 4, right? They're both divisible by 2, and they have an x in common. So here you get x equals 0, and here you get x equals 4. I'm doing this a little half-assed because I don't want to spend too much time on it. Because, again, it's only a fill in the blank. You shouldn't be doing a ridiculous amount of work here. You try to do as much as you can in your head. Now you want to do the vertex. Well, again, you have a formula for it. The B is -8. The A is 2. That's a +8 on top, and that's a 4 on the bottom. That tells you that x is 2. So now you just have to go back up there and plug in 2. And again, it's a lot of work. It's not trivial. 2 squared is 4, times 2 is 8. 2 times 8 is 16. So you get -8 there. So again, I'm doing it a little fast, but this is what you get. So your vertex is x was 2, y was -8, right? I used the formula. I got 2 for x. I plugged it back in to the original function. Got the y. Now, how do I know which way it opens? Real easy. That's a plus. It opens up. Now, you might see something like this on your test. Just hypothetically. There's a negative in front of the x squared, this opens, but there's a plus here. That's not the x squared. The number in front of the x squared tells you up or down the shape, right? Happy face or sad face. So if the number in front of the x squared is negative, down. This one would open down, right? Just showing you. For no particular reason. All right, I'm going to try to bang out the last 3 as quickly as I can. This one is asking you for the discriminant. So you got to make sure it's equal to 0. So make sure you subtract 2x and make sure you put that, by the way, where it goes. You don't put it at the end, right? The x goes in the middle. It's x2, x1, none, always. Now the discriminant is b squared minus 4ac. You did that already in a different problem, right? Problem 3. So b is -2. So you can square that, you get 4. A is 6 and c is 1. I'm done. I don't need to do much more. I can already see, right? 4 times 6 times 1 is 24. 4 minus 24 is -20. That's all I have to see. The discriminant is -20. It's negative, so my roots are complex. Real simple. Discriminant is negative. The roots are not real. They are complex numbers. Now, 7D said it's possible that you could have a parabola that touches the x-axis only once. And I've said this to you before. I've shown you there's many possibilities, right? You can draw your parabola. You hit twice. Trust me, that'll hit the y-axis. You can have the parabola that doesn't hit at all. Or you can have a parabola that landed right there. Who says your vertex can't be on the x-axis? Of course it can. So if you want your parabola to touch the x-axis only once, that would mean that the vertex has to hit there. You can hit twice, you can hit once, or you can hit not at all. X-axis can be missed. You can hit it once or twice or miss it completely. The y-axis you cannot miss. You must hit the y-axis, but that doesn't hit it. But I drew a bad parabola. This parabola would actually hit if you continued forever all the way up there, it would eventually hit the y-axis. They always hit the y-axis. So this question is true, right? You most certainly can touch the x-axis one time. There. You don't got to draw me a picture. Just it's true or false. You don't have to explain. You just tell me it's true or false. Now this one we talked about in class a little. The discriminant. You already know the discriminant could be plus or minus. If it's plus, the roots are real. If it's minus, the roots are complex. But could it be 0? And I said to you in class, yes, it can be 0. So this is true. Now, just in case you see it anywhere in the world, right? Yeah, all over 2a. If this happened to be 0, right? Pretend it's 0. The square root of 0 is 0. So that means you're doing negative b plus or minus nothing, right? Negative b plus 0 and negative b minus 0. That's negative b. So what would happen to you if the discriminant happened to be 0? You would get 1 root. You'd get 1 answer. You don't get 2. The plus and minus is gone. What the hell is plus and minus 0? There's no plus and minus 0 at 0. So if the discriminant were 0, the radical part would just go away. And you would just get negative b over 2a. That's like your vertex. So you would just get 1 point, 1 answer, if that happened, hypothetically. All right, so that's the whole thing. I hope this was helpful. Scan through it. And all I can do is wish you the best of luck.